Hello. In this video, I'm going to explain problem 17 from the 2015 F equals MA contest. In this problem, we're told that a flywheel can rotate in order to store kinetic energy. We're given a bunch of parameters of the flywheel, and we are told to find which expression among the options correctly gives the maximum kinetic energy per kilogram that can be stored in the flywheel. Now, notice that all of the options have different units, since you have different combinations of the parameters rho, sigma, r, and h, and thus we can guess that this will be a dimensional analysis problem, or at least one in which we need to combine the dimensions properly of the different parameters in order to get a dimension of kinetic energy. Now, one thing you may notice is that we have 4 parameters, but we only have 3 I shouldn't say 3 variables, but we have 4 variables, which are h, r, rho, and sigma, but we only have 3 sort of fundamental units, so mass, length, and time. And thus you can see that this is going to be most likely an overdetermined system. However, since this problem is being given to us, we know that there should be some way of solving it. So we know that, going back to our quantities right here, we're told that thickness is h, radius is r. So the dimension of h is just length. The dimension of r is also just length. Now, one thing that this immediately tells us is that we most likely will not be able to distinguish between h and r. Because, for example, if we had h to the power 1 and r to the power 1, giving us the correct units, we could also have h to the power 2 and r to the power 0. So that's something to notice. Then we have rho, which is density, and that's mass over volume, which is mass over length cubed. And finally, you have tensile strength sigma. It says it's measured in pascals, which is the same unit as pressure. Now, pressure is force over area. Now, what is force? Force is mass times acceleration, so that's mass times length over time squared, divided by area is 1 over length squared. So it's mass over length times time squared. And now we're asked to find what is the kinetic energy per kilogram, and let us call that quantity, E prime, so energy per kilogram. And so that will be energy, which is force times displacement, or work is force times displacement, and so that will be mass times length over time squared, and then times another length. However, we also know that it's energy per kilogram, so we have to divide by mass again. And so it's just L squared over time squared. You could have also seen this by the fact that kinetic energy has units of mass times velocity squared. And so when you divide by mass, you'll just get velocity squared. And now the question is how to combine these guys in the right way. Well, suppose that E is proportional to h to the power c1, r to the power c2, rho to the power c3, sigma to the power c4. Then we can match length coefficients. And we get c1 plus c2 minus, let's do this on a new page. Right. So matching length, we will have c1 plus c2 Then rho has L cubed in the denominator, so we'll get minus C3 and then sigma has 1L in the denominator, so we'll get, minus 3C3. Finally, minus C4. That equals 2, since we have L squared in the numerator for E prime. Then matching M, this one just has, we can see rho plus sigma, and that has to equal 0. And so we get C3, C4 equals 0. And finally, we have matching the time coefficients. It's actually just sigma, so we get negative 2 sigma is equal to negative 2. Or negative 2 C4. Negative 2. From the third equation, we see that C4 is 1. And then we get C3 is negative 1. And then from that, we get that C1 plus C2 equals 2, and then minus, we get plus C4 plus 3C3, and that just equals 0. And so we have these guys, and we have C1 plus C2 equals 0. So based on that, we should have E is proportional to sigma over rho, but then we know that C1 plus C2 is 0, but we can't tell more than that, so how about H and how about R? Now, based on all of these options, it's not clear whether to pick D or whether to pick E. So which one is it? Well, this is the place where sometimes in dimensional analysis problems it's very easy to forget to actually use physics, or at least actually use basic physical ideas. Well, you can ask, should H matter? Suppose we keep everything else the same. Well, if we keep everything the same, and let's say, for example, we double the thickness, then it's almost, let's say we double the height h, so we have h and h, to make a new thickness 2h, for example, then it's basically just like two copies of the same flywheel. So we get 2 times the kinetic energy, but we also have 2 times the mass, and therefore the kinetic energy per mass is the same. And thus, it means that it would not be that h should not matter, or that Ke per mass is independent of h. And thus, we know that C1 should be 0, meaning that C2 should also be 0. And this will answer our question. We should not use D, and we should instead use E. Alright, that's all there is to this problem. Thank you for watching, and I hope that was helpful.